Hello friends, welcome back to our channel. So in this video we will be covering chapter number 10, work in energy, class 9th. So in this video we will cover this mind map. So this mind map basically tells us about what work is, what energy is, and what power is. Work is a thing that requires force and displacement that are not equal to zero. Work is equal to force multiply displacement. It's in scalar quantity and SI unit is 1 joule. It is positive when the force and displacement are in the same direction. If they are in opposite, it is negative. If they are perpendicular to each other, and the work done will be zero. Then comes energy. Energy is required to do a work. It's in scalar quantity with the same SI unit, that is 1 joule. It has different forms including kinetic, heat, potential, chemical, light, sound, electrical, nuclear, and there is a conservation law of energy that tells us that it cannot be created or destroyed but can be changed in any form. Power is a scalar quantity and it is the rate of doing work, which is work by time, and its units are 1 watt, which is equal to 1 joule per second, 1 kilowatt, 1000 watt, 1 kilowatt per hour is equal to 1 unit, and it is expressed as 3.6 multiply 10 raised to the power of 6 joules. Then there are some important equations. Work done is equal to force multiply displacement. Kinetic energy is equal to half mv square. Potential energy is equal to mass into gravitational acceleration into height. Work done is equal to change in kinetic energy. Power is equal to work done in particular time. So 10.1, work. Not much work instead of working hard. In our day-to-day life, work is anything that requires effort. But in scientific conception of work, there are two conditions to be satisfied, which are force on an object and displacement of object. Work done by constant force. Work done is equal to force multiply displacement only requires magnitude. So it's in scalar quantity. Since W is equal to F multiply S, we can take F and S as 1. Thus, we get the unit as 1 nm, meaning 1 Newton meter, and the SI unit is 1 joule. Then these are the same positive, negative, and zero work. When it is in same direction, it is positive, opposite, negative, and perpendicular 0. Then comes 10.2, energy. The object and the energy that is required to do 1 joule work is equal to 1 joule energy. So energy is equal to work. 10.2.1, forms of energy. There are different forms of energy which include mechanical energy, which is kinetic plus potential, heat energy, electrical energy, light, nuclear, sound, and chemical energy. 10.2.2, which is kinetic energy, which tells us about kinetic energy formula derivation, which is we know that work is equal to energy. So we can say ek is equal to F into S, and through the second law of motion and the third equation of motion, we get to the answer of S is equal to V square minus U square by 2A. We solve it next and we get the answer where U is equal to 0. So the kinetic energy will be half mv square. Then comes also work done is equal to change in kinetic energy. So work done is equal to energy final minus energy initial. This is the work energy theorem. 10.2.3, which is potential energy, that is the energy possessed by an object at rest, and when we exert a force on an object for displacement, it stores inside object as potential energy. So the energy is converted into potential energy. Potential energy of an object at height, we get the answer to be mgh, and here is the derivation. Then comes our various energy forms in convertible. So I have given here examples, and yes, it is every energy can be converted into any form, and examples are torch, mic, windmill, where chemical in torch chemical energy is converted into electrical, and this converts into light and heat. The same in mic and windmill. Then the law of conservation of energy, which tells that energy can neither be created or destroyed but can be converted. Also, initial energy sum is equal to final energy sum. So here is the application also, where we have got the example of pendulum. At the point O, the kinetic energy will be slightly higher than that at the starting point A. Then it will be highest at B, and it will come rest for some milliseconds, where its potential energy increases a lot. So when the potential energy increases, the kinetic energy decreases, and vice versa. Then comes the point that always kinetic energy plus potential energy give us a result as constant. The rate of doing work is defined as power, and the unit of powers are here, and for commercial use we use 1 unit. 1 kilowatt per hour is equal to 3.6 multiplied 10 raised to the power of 6 joules. So along with this, we have completed this chapter notes, and it was a very easy video. I have covered the exercises too, which will be explained in the next video. Till that time, please like and subscribe my channel for the next video, and surely watch my other videos for better understanding and conceptual base for class 9th. Thank you.